Okay, we started discussing the features of Python and how to use Python shell and write new programs, as well as we discussed how to get an output. Then the basics of programming like declaration of variables and the data types. So this arithmetic operators, data types, and the arithmetic operators discuss about addition, subtraction, multiplication, division, exponent mean the power, floor division. Floor division means so when you divide, after you divide in, what is the floor value? For an example, what is the integer value basically? That's very simple, right? When you divide, what is the integer value? That is the floor division. So let me show that, okay, here. So if 4 divided by 3, the floor value is 1. So what is the integer division value? And the modulus means the remainder value. 7 divided by 2 or 7 divided by 4, the remaining is, so this is the floor value. 7 modulus 4 and it gives the remainder. So 7 divided by 4 is equal to 1, remainder 3. Understood the difference? So what is the remainder value of the modulus and what is the floor value or integer? The simple, huh?
Yes, sir.
Right. So then what about this one? 34, 10. What is the answer? 34.
3.
Yeah, it's 3. Then what is the answer if 34 modulus 10? Yes, 34 modulus 10.
4.
4, yeah, it's 4. After dividing it, 3 means 30. So you have 4 remaining. So you call remainder, right?
Yes.
Okay, then. Let's move forward. Then the operator precedence. So which is given the priority. So we did this exercise to see the brackets and the multiplication. Those are given the priority, but addition, subtraction come later. So then discuss how to give an output and multi-line output. That part we discussed, and how to give input by giving an
Yeah.
input, yeah, and converting that to integer. We discussed that. Comments. So comments are in Python comments. We have to use, it says that in your book it says that we have to use Python comments to declare the variables since so no declaration is there. So to explain that it is advisable to use Python comments. The comments are starting with hash. But there's another way, but this is not true comment. This is not truly comment. You can put 3 single quotations and here you can finish 3 single quotations, but that is not a comment. So that will make this part string. That will make this whole part string, but it will be treated as comment because nothing to do with this area, nothing to do with this area. So this will be treated as this like a multi-line comment. In Pascal here, there's a multi-line comment. So it's similar to multi-line comment, but this is not multi-line comment, right? This is like a cheat. You make whole part a string. String එකක් කරන මුළු part එකම then it will behave as a comment. No value is there. Understood?
Yes.
That is just a cheat, right? That's not a comment, that's a cheat, but it's applicable. And then data types. So basically in Python you have int, float, character. You don't have character, right? But still you can get the character values like this, but you can say, okay, what is the ORD of character A? It will give us the code. It is 65. What is CHR of 65? It will give the character. So so we learned this one in chapter 1 or 2. We learned this one. So so anything is represented in binary using a number. So similar to that, any letter has a value. So 65 is ASCII value of A. 66 is ASCII value of B. Then I'm asking, what is 66? Give me the character which has the value 66. It will give me its character B. So even though you don't have characters. For an example, if I ask what is the type of, so these special commands, though these are no need to remember these commands, but still you can check this. You can use this to learn. Right? In your exams, they will not ask these things, but this can be used to learn. So I can ask what is the type of A. It will tell me it is str because it will not tell it is character. Even it is a single character, it will be treated as str string here str string as key, right? Still, if you use if you use multiple characters ABC, still it is str, right? So if you ask type of tree, it says it is int. If type of, please remember, take a print screen or screenshot of these things. Since you have examination, no need to write everything and no need to remember everything, but just have a screenshot. You can test this. This is in shell, right? This is not in new file. This is in shell. In shell, you can test this. In new file also you can test, but in shell, it's very easy to test. If I ask 3.0, can you tell me the type? 3.0, what's the type?
Float?
Yes, float. Float. So what about this one? If I ask type of 0x AE, what is the type? 0x AE.
String, sir.
String? No,
Yes.
it's number. It's integer. This is given in hexadecimal format. This way, right?
Oh.
Modern put like check in packing right 0xAE. It is integer. This is hexadecimal, right? AE is hexadecimal. I can give octal similar to this 0 0 then I can give the value 45. Then it's also integer because 0 represent octal, 0x represent hexadecimal, and 0b represent what? 0b is for binary. Understood? If you cannot understand, please let me know. These are simple.
I understood.
That's why I'm doing in faster way. Oh, you can, one of this is, you in shell you can say 0x 1A9. So it will automatically convert that to decimal. If you say 0O some number, it will be automatically converted to decimal. If you say 0B some number, it will be automatically converted to. So you can test your answers by using the shell. If you type the number, shell will convert that to decimal. Okay.
Yes.
So these are integers. And what about this? If I ask type of 3.5 plus E10. What is this? Sorry, plus E plus 10. I cannot remember the exact syntax. Sorry, E plus 10. Yeah, E plus 10. That is float. What do you mean by E plus 10? 3.5.
Times 10 to the power.
It is scientific representation. Let's say E plus 3. It is 3,500. 3.5 into 10 to the power 3. 3.5 into 10 to the power 3. If you like 10, it's this number. You have like 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So here you got 3 positions. Here you got 10 positions. Altogether, 9 zeros. Understood? Hello? You're there or not?
Yes.
Hello?
Yes, sir.
Yeah, you understood this?
Yes, sir.
Okay. Then what about if I write something like 3, 3, 4, E minus 2? What is the value?
It will go at 2.34.
Yeah, 2.34. It's correct. Seems you understood. Okay. So that's how you get these scientific representation of floating point numbers. And the next one is bool. For logic, like true, if I ask type of true, capital T R U E, must start with the capital T, otherwise, if simple T, it's wrong. So I have to tell capital T true, it is Boolean, and then capital F false is also Boolean. False is also Boolean. Okay, these are the data types available in Python. And a very quick review of data types. So let's move. And now actually we are going to learn some more data types. So here date value and monetary value. It doesn't have date and currency values. Is you can so you can create using same integers, same thing, right? And Boolean
Yeah.
expressions. So in Python, this is how you check whether is it equal to, not equal to, greater than, less than or equal to, and greater than or equal to. So these are self-explanatory. I'm not going to explain. So here 5 not equal to 10, it says true. If I ask 5 equal to 10, it says false. It's not equal. Right? These are self-explanatory, right? Not equal is
Yeah.
symbol is exclamation mark and equal. Exclamation mark and equal. Okay, then the logics. Logic means you can ask here 5, so 5 not equal 10 or 5 equal 10. So it will give true. Why? 5 not equal 10 is true. Or 5 equal 10
Yeah.
is false, but still true and false is true, no? Because it is O gate, no? O gate, if at least one is there. If both are false, only O will give false. For an example, if both are false, 5 greater than 10 or 5 equal 10, then it says false because both are false. Right? In AND, if I use AND, so it will compare both again, both are false. Both, if 5 less than 10, so let's edit like this, 5 less than 10 and 5 less than 10 and 5 greater than 10. Is it correct or wrong? False or true? 5 less than 10 and 5 greater than 10. Is it true or false?
So, but so they're both the same.
Oh, yes, sorry, both are same. Then that is true. That is true.
Yeah.
Right. If it is 5 greater than, then that is false. Both are, if both are true only, and will give true. If both are false only, or will give false. If both are true only, and will give true. And not is the reverse. Basically, you can ask not
Mhm.
5 equal 10. It is true because 5 equal 10 is false. Not false is true. There is a reverse. Okay. So those
Yes.
are the logicals. Then if else we learn how to use if else we learn. So you use indentation. Then if else, yes, multiple if else here, multiple if else it go as if elif and else. So this part we didn't discuss, but seems it's self-explanatory. Oh, I'll give small exercise quickly, very small one. If elif and else, this is how Python use syntax. Just since you are new to Python, let me give this as example. Okay, let me take 2 marks, 3 marks. Math mark equal int input input enter marks, and similar to that maths Let's take English and science marks. Here ENS, English and science mark. And then I'm going to tell if, so let's take total equal M plus E plus S, and average equal total divided by trade, self-explanatory. I think you can understand. If not, please tell. Then if average is greater than or equal to 75, I'll say the grade is initially, it's blank, nothing. If this is greater than or equal to 75, I'm telling grade is A, and I need to apply some more ifs. Let me copy. Then the second one, Control C, copy V. It's not taking V. Okay, the second one is taken using elif. Elif, that is one difference. It's not else if, it is elif. Elif it is greater than or equal to 65, let's say it's B. And then elif and elif and finally else. Elif it is greater than or equal to 55, let's say C. Elif it is less than greater than or equal to 45, let's say it's S, and otherwise F.
Oh, this is like case, sir.
No, these are if else. So you have
I
if
mean,
else.
it's sort of like case.
No, it's not case, no. So it's switch and case, different thing. Switch and case, different thing. Switch and case, you can't give a range. You have to give the exact value. So I'll explain switch and case also.
Oh,
So it has separate thing. So here you can see A,
oh,
B, C, A, B, C, S, and then else you can say as F. Grade is F. So this is when you have nested if or multiple ifs, multiple if else statements. You can write down this or you can draw this or take a screenshot. So then finally you can print total is then the total, average and rate. Total and average is AVG and rate is the rate. So let's run the file. You name as ex11.py. So it's asking me the maths marks, science marks, and English marks. It says total is this one, average in this, and you got A. Right. I can assign this to function to run this again and again. Last day we discussed about function. How to define this as a function? Can you tell me? How to make this a function? Whole thing. What's the keyword?
using
Def.
DEF.
Yeah, def. Def, you can say def is, let's say def marks. Function name is marks. And colon, then you have to indent everything under that. Put in a tab. Save. Run this. So then I have to call the function actually marks. First call of the marks function, it says, okay, enter marks. You can say grade is C. Then I can recall the function without running the file. I can recall the function. So that is the advantage. Now grade is A. I can recall the function marks. So grade is B. Okay. You can take a screenshot or print screen. Screenshot. Because the writing it will take some time. Finished?
One second, sir.
Yeah.
Done, sir. Okay.
Right. Okay. So I think you understood the concept, right?
Yes.
So since you asked if else, let me explain if else too. Since you asked about if else, sorry, switch case. Switch case is different. Switch case you have to point the exact value, right? So let's say let's say x input or int input. Just to blank input. That's enough. So int input, or you can say even you can give blank input, right? Blank input means when you run, it will just ask the input. No message, but it will ask for a input. Yeah. It will ask for an input. Then I can give. So that is the blank input. So no message, but still you can ask for input. So then let's say input, then switch. Switch on X. Switch on is case 0. I'm going to print X is even, break, case 1, print X is odd. So if you have specific cases, then you can write this case and all default print some other. Okay. So switch case is used basically if you know the cases. For an example, so let's say this is y and x is taken by y modulus 2. So after dividing by 2, if remainder is 0, it's a even. If remainder is 1, remainder is 1, it's odd. So let me run the code to show you. Okay, let's save this. So something wrong here. Switch X. Cannot remember the stuff. I have not used for a long time. Switch. SWITCH. Switch X. It's correct. Switch X. So whether check whether you have switch case. Switch case here. Here. Select case. In Python, it says Python does not have switch case. Oh,
Yeah.
is that so?
Is it old?
Yeah, I let me check because I cannot remember this. Right, let me check this. I think we have. I cannot remember
Because
this.
I was reading the textbook yesterday. That's why I asked the else if you were doing. I asked, is that also case? That's what they mentioned in the textbook, that there's no case. They only use the else if.
It seems no. Else. Shorthand. Because I'm using many languages, it's always confusing me. It seems it doesn't have. But the syntax will be something similar. Switch case, the syntax will be something similar. So here, yes. In Java, yes, here you can see this in Java and other languages, as, but in Python, it doesn't. Right, Python approach. So it has implemented using this, right? So it has used the functions. So three function to return 0, 1, 2, and the switching between three functions. So this is advanced, but it won't come to your level. So here they have implemented this using functions, returning different values, then use that function to switch between those, right? So, but that won't come, don't worry. That won't come because it doesn't have the implementation, proper implementation. Okay, let's move. So anyway, the format is something like this. So if you're using VB or Pascal, or I think since it is not there in Python, they won't ask because you can write the answers in any language, no? So if it is not available in one language, they cannot ask. That is not fair, right?
Yeah.
Okay, let's move. So you can that's what you are asked this. This is not switch case. This is called multiple if else. This is multiple if else. This is not switch case. Switch case it has different implementation. So it always look at the specific value, only one value at a time, not the value range. Here is a range, no?
Yeah.
Okay, then sorry, it's my mistake. Right, let's move. In your book, the next thing, iteration, we discussed for loop, and this one discussed reverse for loop discussed, and this one we didn't discuss, right? There's another for loop. This one we didn't discuss. Today we are going to discuss this. Please remind me. So this one we have not discussed. And while loop discussed. Arrays. Okay, now it's about arrays. Basically, it's about lists, right? It's about list in Python because Python has separate structure called list. It's not array, it's a list, but the behavior is similar to array. Behavior is similar to array, right? Okay,
Yeah.
so let's write the other way, the other for loop. Anit for loop එකත් අපි ලියලිමු. Let me write that, the other for loop. So that is used for strings and lists and tuples and dictionaries, those things basically. So Python has three data structures. Better write down this one. There are four data structures for basic data structures in Python. The first one is list, is mutable. Means can edit the items. Can edit the items. The second one, tuple. It is immutable. Cannot edit the items. So that's the only difference. The third one is dictionary. it has key value pair, and we can declare the keys. We can declare the keys. So that is dictionary. And the last one is set. A set of unique items, unordered, unordered, unorganized, not organized. Set means, in mathematics also you learn something called kulaka or sets. So that is similar to this set. So these are the 4 basic data structures in Python. Lists, tuple, list, tuple, dictionary, and set. Okay, let's define one. So my list, I can declare list using the square brackets, and I can put the items. You can put any kind of item. Any kind of item. In a list. Anything you can put. If it is string, you have to quote. Other things you don't want to quote, you can mention. Any kind of item can be put in list. And then the second one is tuple. My tuple. Tuple is almost same, similar to list. The only difference is the bracket, and not only that, it is immutable. You can't edit the item after putting the items. You can't edit the items. It's fixed. Read only. So basically, this is read only. Then the dictionary. Let's say my dictionary. My dictionary. So the first one, let's say 34, then you have maybe name, and the name equal to something like Sedas, and then let's say you have age. You can declare the key and value. You can declare the key. Key means the first thing, and then the value. This first is key, 34 is the value. Name is the key, Sedas is the value. Age is the key, 18 is the value. Ismail is the key, true is the value. Likewise, you can declare the key and value. Then you call it's a dictionary. And the last one is set. My set. Set is again curly braces. You can write the items similar to list. Sorry, my mistake. But when you have multiple items like 23, you can see 1, 2, 3 times. 34, you can put C 34, 1, 2, 3 times. But set will ignore the second one, the first, second one, and the third one. It will take only one unique value. So other values, the duplicates will be dropped from the set. Once declared, the duplicates will be dropped. Please write this. Please write this. Let me show how we can use those things in next section. So let me save this. I'm going to declare this data type, and I'm going to print all the items in the list. So that's where the for loop can be used. For I in my list, you can print that item. let's end this with space, end with space. So similar to that, you can print items in tuple, items in dictionary, items in set. Let's see which is working and which is not working. So this is your tuple, this is your dictionary, and this is your set. So let's save this and run. You can see the first one is done. It's finished. Right. Let's keep blank line after each. Otherwise, we cannot recognize. Now you can see the first one, second one, third one, and fourth one. So the iteration, you can print items. It's iterable. You can iterate anything. You can iterate through list, tuple, dictionary, or set. So please notice the set. You won't get the duplicate values. 23 only one time. Yeah, you can. 34 only one time. It's not organized, right? It's giving on according to order. It's not organized, not ordered, nothing. Not according to the given order even, but it filled out the duplicate values and display you the unique values. So this is how you go through list, tuple, dictionary. So you can use, instead of I, you can use anything. Instead of my list, my tuple, you can use any variable name.
Yeah.
That is not compulsory to use the same name, right? You can use any. Just understand the logic. Please try it.
Yes.
Finish. Or still writing.
I finished, sir.
Then let's move. Right now, you know how to get guidance. The only thing is, so let's move. This iteration is possible for all four. Then let's change item. I'm going to print. Okay, I'm going to change the item first. In my list, zeroth item or the very first item, the initial item, I'm going to give a value of 13. So let me apply this, the same thing to the tuple, dictionary, and set. The second one, my tuple, and my dictionary and my set. I'm going to change the first item. So see what happens. So first iteration done, but here it gives an error in line 30. Line 30, the tuple object does not support item assignment. Tuple, you can't do this. Let me comment. This is interpreter, right? This is interpreted language. So it will go line by line, right? So even I correct this, it can generate like another error in the next line. So let's check. Let's check that. Done. Here, set object does not support item assignment. All right. So then let me comment this. Run this. Okay, no errors. It seems dictionary you can assign the items and then dictionary and list. So let me print the list after adding this item. Let me print the entire list. Print my list. I'm going to print the entire list. Here also, after adding this item, I'm going to print the entire dictionary. Right?
Yeah.
Now you can see here. So in your, I need space. Some spaces, let's add 2 spaces. 2 spaces. 2 line gaps. First one, second one, okay. Now you can see 13 is added to the 0th position. Here, 13 is added to the 0th position of list. So 34 is removed. 34 is removed from the list and 13 is added. So what about the dictionary? Dictionary, it is added to the end. It is added to the end.
Oh.
Why? Because you don't have this key. 0 key was not there. If you say 1, in dictionary, 1 is there, no? It's there. If you give 1, you can see that. Okay, here 13 is added to that. 13 is added by removing 34. Then 13 is added by removing this. Yeah, this one. Again removing, after removing 1, after removing this one, it's added. Here it will print the keys, right? It will print the keys, not the values. 1 is same, name is same, but values it will not be printed. When you iterate, it will print the. So if you want to print the value, I think you have to call like in dictionary print I dot value maybe. Let me check, right? I'm not sure. Off. I dot value. No. So you have to tell like this in dictionary. You have to tell in my dict the ith item. Then it will print the value. You can see here 34 Sedas 18 and 2. Right? Otherwise, it will print the key. Understood? In my previous one, it will only print the key. Now, when I say my dict I, then it will print the value. Now you can see 34 is altered. 34 is altered and added 13 instead of that. So what happened if you give something like this? If you give in here also, this item is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So what happened if I tell C 10? So let me show that.
There would be an error.
Let me show that. It says out of range. It won't be added. That's why I just want. So if it is a dictionary, if key is not there, so remember that. If it is a dictionary, if key is not there, key and value both added. So this is actually item assignment. So let me write an item assignment. So what I have to tell here, list will support change in existing items by giving the existing key, right? So that is about list. So what about this? You can give existing key and change the existing item. So here, the second one, what about the second one? Tuple is read only. So it will not support dictionary. It's similar to list, no? It's similar to it will support or dictionary. Will support change in existing item by giving the existing key, or if not an existing key, what will happen? If not an existing key, yes. If not an existing key, what will happen? It will add key and value both to the end, right?
Right.
So if it is not existing, non-existent key, it will add non-existent key. It will add the key non-existence. If it is not existing, it will add key and value both to the end. That is about dictionary. So what about set? Set is not allowing to access or change by using the key. Set is also kind of read only. It does not allow you to change using the key because it doesn't have key. Actually, it doesn't have key because it is not ordered, unorganized. So all these three have keys, but the last one, it doesn't have keys. So you can't access using keys. Understood?
Yes.
Access in items. Access in items. So all four will allow you to access items except the dictionary. So you can print you can print my lists first one. It will print the second one, right? Because it will start from 0. So what is the second one? 56 will be printed. So if I use this one, can you tell me what is printed? Print my list, then my tuple 4. What will be printed? Print.
Oh no.
Print my dict age. Print my set 0 something. Won't happen. So here everything will happen, but so can you tell me? So what's printed? My list one. This is my list. What is
56.
one? 56. Then my tuple 4. My tuple 4.
45.
0, 1, 2,
Oh, sorry.
3.
Hello.
Hello. My age. My dictionary age.
18.
18. And my set 0. It's not organized, so it will give an error. So
Right.
it's not organized, so it will give an error. So let me run this. Okay, first one off. 56, hello, 18, set. No, not indexed, not organized, not indexed. So cannot do this. Right. Change in items is possible. So you have to remember these things, right? Change in item is possible only in list and dictionary. Tuple is read only and set is not organized. Right. Then the thing is add in items using the key. You can do it use for dictionary only. Because if not exist, it will add the items. But you can't use that method for list. But list is still possible to add the items. So add in items. Add in items. It's possible to add item to list, but you have to use like this, my list dot append. Then you have to append the new item. Let's say 200. And then you are going to append another one. 500. That will add. Then let me print the my list. Print blank and print my list. You can see it will be appended. So this dictionary also you can append the items. So two methods. So dictionary also you can append items. You can either give the index, some kind of index like let's say city, non-existence, and you can give the value candy. Even though it is non-existent, it will be added. And you can try to do this my dict dot append, but so you can try to give key and value. So let's see whether it's accepted or not. You have to always run and check this otherwise. Okay, you can see here this is appended 200 and 500 appended, but here you can't append dictionary, no attribute called append. But you can add like this. You can give the key and that's easiest way. But other than that, you don't have.
Right.
Here, let me print and print the mark. So please write down the additional notes, whatever I had.
Okay.
Please write down this. Let me show by running cities added to the last. Then let's move to the next one. So now we know the basic structures and how to access the items in those structures. And those are basic structures. By using those structures, so it is required to develop some other structures like stack, queue. Those structures can be generated. And so not only that, so there's something called data structures. Basically, data structures are used to store data. But to manipulate or to handle data, you have something called algorithms. So today's lesson and the main focus is about that, but I had to discuss the basics as So you have not learned that previously. So what do you think about Python now? Is it easy or difficult?
I think I'm getting the hang of it.
That's easy, no? That's easier than, because
Yeah.
otherwise you have to remember a lot of syntax. No, here you don't want to remember much syntax. Only thing is you have to
Yeah.
understand the theory and the concept, then you can code it. So without much worries, right? So here they have given
Yes.
some other methods to implement the list. So this first method is actually implementing empty list and append the items. Then this will be appended as 0th item, first item, second item, 0, 1, 2. Because list is initially empty and you append in 0, 1, 2. So the second method is again you give the item list and assign. So that is the method that we have used. Or the third method you can this is the third method. Third method using a loop. So in the list 0 for I in range, for I in range 100, then what will happen? So it will create a list. For an example, okay, let me show you in the shell. So if you use, let's take a new shell. Okay. So if you use the third method or the list, let's say equal 0 for for I in range, for I in range, let's say 10, 0 for I in range 10. If you give like this, sorry, you have to give inside the brackets, right? In range 10, so I forgot that. Then it will assign zeros 10 times. So if I asked you to print list 2, here 10 zeros. Because you said 0 for I in range 10. Understood that short method.
Yeah.
If you put like here, so this for I in range 10, then what will happen? Then this list will generate so 10 empty strings. 10 empty strings. So anything you can give. So that's how it's generated. So if you put, let's say, if you put I for I in range 2, then what will happen? List.
10 eyes.
Because I is changing, that I it will assign to the list 0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
Oh.
Right? So you can use same I.
Oh, okay.
Same I for I in range 10. So you can, if you want, you can put I into I for I in range 10. Then what will happen? So it will calculate and then it will assign. So 0, 1, 4, 9. So the square numbers.
Ooh.
Right? Likewise, you can
Yeah.
hear the item. So what's going to do with the item? Here the loop. Loop says this item should be assigned the list. Right? So you can use the previous one also, right? For an example, I in range 1, 111. So you know when it is 111, what will happen? It will start from 1 and go up to 10.
And a 10.
Otherwise, it will start from 0, no? If you want to store from 1. So I in range 1 for 111, or you can go reverse, whatever. So same for loop we have used with the same different parameters. Same for use for loop with different parameters, and you assign the item. That is one line. So that's why it's super fast, right?
Yeah.
So otherwise you have to write a lot of codes to do this, no? So you have to get the
Yeah.
number, get the value, store in the list, but this is very convenient, right? So and the next one here, this is another one. So you can create a list, let's say list 5, some list, and you can give multiplication of existing list. Yeah, I'm going to multiply this by 25. So then the list 5, you can see it's 25 blank places. A single list with 25 blank places. Understood?
Yes.
You can multiply by, so in Python, there's Python, many things are possible. For an example, you can put hello, and this is special one. You can multiply it by 10, then it will give 10 hellos.
Oh.
Multiplication can be applied for strings. So you can make it 10 times easily. But it's not happen in other one. Huh? Don't remember these things in other, because VB.NET and Pascal, this won't happen. So you can even multiply this one. So this list can be multiplied. Item can be multiplied many times and assigned. So these are the methods that you can use to assign a list. Okay, so all 4 methods we discussed. The first method starting with empty list and appending. Oh, you can even start with this kind of list and append later. And the second method is declaring the item. The third method is you can give a loop and give the item, fill the items. And the fourth method, you can take one item and multiply it by the number of items over the times. Those are the ways to create a list. Right. Okay. So these are the structures basically. After having the structure, you have to write an algorithm to manipulate that. For an example, okay. So if you have a list like this, okay, marks, you have marks, and these are the marks. You have marks of the students. Now you need to sort this. You are not going to print, you are going to print these marks according to order. You can, maybe you can try with this one, marks.sort. Right. So then if you print marks, you can see it's sorted in the ascending order. Right. Then marks.sort, you can give here, without giving a key, you can say reverse equal true. Then the marks will be sorted in descending order. Right? So if you have a list, you can do button in your examination. So basically they want us this sort function directly. They want you to write an algorithm to sort. So there's an easy way. I know this is very easy. You can either sort or sort in descending order. So, but the thing is ascending or descending order. But in the examination, they will ask you an algorithm. That's where the bubble sort comes. That's where the selection sort comes. That's where the insertion sort comes. So you should know the algorithm. Okay, now we are going to learn that algorithm. And before that, I think you have some important thing to write down. Or if you can just refer to the screenshot, you can take a screenshot, whatever. If you want to write down, please write down. Or if you want to take screenshot, take it. Which way you prefer, writing or?
I'll write it down.
Okay. Right. Then let's go and develop an algorithm to do this. So now sorting will do that, but the thing is in examination they won't give marks. So if they have asked you to write an algorithm, don't write this marks.sort or marks. It's not useful in the exam because you should know an algorithm, how to write an algorithm. So let me suggest there are 3 basic algorithms, but as you ask, so don't you have the other algorithm? You have only bubble sort.
Yeah, but only bubble sort is coming, sir.
Arrays here. So let me go through the book. This one, you know, the 2D arrays. Actually, I list of lists. Actually, you have list of list 2D arrays here. List of list, or you can here the first one and second one. The first one and the second one. This is how you create 2D arrays. So you can try these things, right? LED dimensions and.
Okay.
So because Here they have given this, no? Built-in character, built-in functionalities, CHRORD. I said that.
Yeah.
Nice there. So these are some built-in functionalities. Slicing, and anyway, this part actually I'll keep for the moment, but I'll discuss, right? This part I'll keep for the moment since you need the exam focus. So, but please go through these things because it also belongs to the chapter, right? So then the handle text files also not come, no?
I'm not sure. I don't think so. It
Right, okay.
mentions only.
But yeah, it has those things. So I saw that it has those things. I can do this, but the thing is, for the moment, I'll focus your exam and skip this, but that won't matter.
Yeah.
After the examination, I'll anyway complete that part.
Yeah.
Right? Otherwise, it's like skipping and go.
Okay.
I don't like that. Personally, I don't like that. Skip one part and go to next part. But since your need is that, I have to address that first now. That's why I'm doing that part. Right, then structured programming, and here you have the procedures. Def, we discussed the procedures, Python procedures, processors, functions. This part we discussed. Giving parameters, yes. And then here functions inside functions, returning functions. You can just try those codes. There are more functions, function styles there. And that part actually we have almost done, no? Functions, procedural programming.
Yeah.
That's completed. So then software development, is it again?
No, it's not.
It's not there.
No, it's chapter 14 or something, right?
Yeah,
What's
chapter 14
say?
we have done. Chapter 14 we have done. That is functions. That's done. Then this one is basically chapter 15. Chapter 15, under that you have writing programs, basically. Sorting, actually, I just want to find where sorting is listed. So that part anyway, 15 is not there, no? So where this sorting algorithm comes? Under which chapter? 17.
Let me check.
Yeah, data. I think it's
Let
under
me check
coming under this
in
one,
the
data representation and algorithms. 16, no?
chapter 16.
Data representation and algorithm, is it coming under the particular topic or?
Give me 1 second. So let me check.
No, I just wondering which chapter this sorting is added because I didn't read the entire book. I just went through the areas that relevant to you.
Yeah, I'm checking. So.
Okay. Then
only these two, right, sir?
Yeah, you have mentioned me the bubble sort part as well as the queue and stack part, stack and queue part. That is anyway, it's there in the upper chapters. That means chapter 20, 23. So you can see the other sorts also there, insertion sort, selection sort, and all, and the advanced data structures like tree, hash tree, dunes. And here stack queue, you can see it's coming under chapter 23. It's coming on chapter 20. But anyway, okay. So can do. So let's go and learn that part quickly. Okay, now I'm going to implement this. And first of implementation, what I'm going to do is I'm going to explain how this works. I'm going to explain how this works. Okay. First part is my explanation of bubble sorts. So let's say you have a list. You have a list. I'm taking small list. 1, 2, 3 and 4 items are there in the list. Let's say maximum 5 items. So this can be applied for many. what's happening in the bubble sort? What's happening in the bubble sort is, so it will first compare the adjacent items. So the neighbor, the adjacent item is compared. So 23 and, so this is, if this is a list, 23 and 43 compared. So which is largest, 23 or 43? Which one is the largest?
43.
43 is largest. So if you have the largest number in right side, you are not going to change that. You keep as it is.
Okay. Yeah.
Next step, you check 43 with 21. 43 with 21. Which is largest?
43.
43. So if the right side one is smaller one, then what you're going to do, you are going to swap these numbers. You are going to change these numbers or swap these numbers. Okay, I'm going to swap this number and write this again. 23, then 43, here 21 will come here and 43 will go here. That is the swapping part. And after that, 43 will be compared with 43 will be compared with 12. So what, which is the largest? 43 or 12?
43.
Still 43, no?
Yeah.
So then 12 will come here and 43 will again move forward, because when you compare 43 and 12, then 43 is largest. Then you compare 43 with 56. Which is largest?
56.
56. You keep 56 as it is. So this is end of first round. End of first round. Then you go to the second round. 23 and 21, which is largest? 23, 21.
23.
23 is largest, so 21 will come forth and 23 will go. 23 and 12.
23 is larger.
Yeah, then 12 will come here, 23 will go. And 23 and 43, no change.
No change.
43 and 56, no change. Okay, this is end of the second round. End of second round. So then it go to the third round. 12 and 21, which is largest? 21 is largest, 21. So it will move forward. And 21, 23, no change. 23, 20, 43, no change. And then 43, 56, no change. This is end of the third round. Right, next fourth round. 12 and 21, no change.
Yeah.
23, 21, no change. 23, 43, no change. 56, 43, no change. If no changes are happening, then you are going to finish after this. So let's write in check and finish after this as no changes or swaps. No swaps, so you have to stop. So when you stop, when there are no swaps, the list is sorted. So how many rounds you required to sort this? 1, 2, 3.
3.
Sorry. In the worst case means if this list is sorted descending order. If all the items are upside down, means 56 here, 43 here, 23 here, 21 here, and 12 here, then it will take at least, it will take 4 rounds, n-1 rounds, 4 rounds to sort this. That is the worst case. Best case, if it is already sorted, it only need 1 round, no? It only need, because it has to check. So after checking, it found that all no changes. No changes means it's already sorted. The best case, so you should know these things. Best case, no changes, no swaps, and 1 round. Worst case, you need n-1. So if there are n items, you need n-1, n-1 swaps, and n minus 1 rounds. The average case, basically average case, we call it's similar to n minus 1, somewhere around n minus 1. So assume that this n is like 100,000, very large number, then this 1 can be ignored. If this is 100,000, like very large number, this 1 can be ignored because 1 is very small. So you tell this complexity of this algorithm. Complexity of the algorithm is n squared, n squared, n to the power 2. Why? For very large number, you can ignore 1. N into 1 is n squared. So this is written as in big O notation. Big O notation. So there's a special notation to measure the complexity of algorithm that is called big O. You write same O but little bigger. Big O n squared. We call this algorithm is complexity of big O n squared. Big O n squared. I just told you the idea. What is the idea? Idea is in the worst case you need n minus 1 swaps and n minus 1 rounds. Totally n minus 1 into n minus 1 is closer to n squared. Understood?
Yes.
Right. So that is the theory part behind that. Okay. So let's implement this. So that is what we need. So let me comment all these lines. So not required. This is the first round. Initially, the first round, second round, and third round. You have to understand the concept, right? This is called bubble sort. Why it is bubble? It's going like bubbles. The first bubble, it will propagate to the end. The second bubble, it will again propagate to the end. Likewise, the first round, it will find which is the maximum. The second round, the next maximum. Third round, the next maximum. Fourth round, the next maximum. And it will finish. And after that, you can see it's in order. Okay, so this is called bubble sort. So I said that so even though it's in AL, if you have fundamentals, that's why I again highlighted the fundamentals when you were telling that we need to do this, and this. I said, please focus on fundamentals, because if you know the fundamentals, the advanced part you can easily understand. But if you don't know the fundamentals, the advanced part will be very difficult. Right. So fortunately, you agree to follow the fundamentals, right? So then I think now it's easy for you to understand the algorithm because you know the fundamentals or the basics.
Yes.
Right. So let me write the code. Assume that this is my list, marks. And I'm going to write the code. These are my marks. I'm going to sort this for I in range. I'm telling length of marks. What is length of? Length means the number of items. What is the length? 1, 2, 3, 4, 5. So value of this is 5. Length of marks is actually 5. I can give like 5, but rather than telling that, because if there are like million items, I can't count. No. So easy way is if there are five items, I can count. But if there are million or some big number, I cannot count. No. Then I can say length of marks. That's easy. So what do you have to do for I in range length of marks? If the marks, the ith element is greater than marks I plus 1th element, the next element. So what do you have to do? You have to swap. You have to swap. But here be careful because I is ranging from 0 to, can you tell? I will go from 0, 1, 2, 3, 4, no? Because length of marks, no?
Yeah.
Here it's 5, no? If I is I in range 5, what are the numbers? I in range 5 means 0, 1, 2, 3, 4. It will not access 5. It will go up to 5. Right? This is 0th index.
Yeah.
This is first index. This is second index. Third and fourth. But when you are telling I plus 1, what will happen? It will go to 4 plus 1. No, the last round it will go to 4 plus 1. Is it a
Yeah.
valid index or invalid? Out of range?
Invalid. It's
Yeah,
out
it's
of
out
range.
of range. So I have to tell minus 1 here. Why? Then it will go up to 0, 1, 2, 3 only.
Yeah.
Because minus 1, this will become 4 no? If you cannot understand, please let me know. This will become 4. When you give 0, 1, 2, 3, I minus 1 or a length of marks minus 1 means 4. Then it will go 0, 1, 2, 3, 4. Then I will change from 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. 0, 1, 2, 3. 0, 1, 2, 3. But I plus 1 will go from 1, 2, 3, 4. No? So when I is 0, what is I plus 1?
1.
1. When I is 1, what is I plus 1? 2. When
2.
I is 2, I plus 1 is 3. When I is 3, I
3.
plus 1 is 4. 4 means the last
Yeah.
item. No?
Yeah.
Okay, it will check up to the last item, and swapping happens like this. Swapping you can make like this. You can say, you can take a temporary variable. So assume that you have a tea cup and coffee cup. You have 2 cups with you, tea and coffee. Now you are someone is asking you to put tea into coffee cup and coffee into tea cup. So how you do the change? So 1 cup you have tea, the other cup you have, the other one you are having coffee. Now you are asking, someone is asking to change both. What can you do?
Swap.
So how to swap? You need additional cup, no?
Yeah.
Otherwise you can't you can't just interchange that, no. At same time you can't do that, no. So if it is like
Yeah.
2 balls, if you have 1 ball in your left arm and second one in your right hand, first one in right hand and second one in left hand, what you can do is you can just put it up and then change the hand and catch it. But can you do that for tea? No, it's
No.
not. It's kind of difficult thing. But both methods are available in Python. Fortunately, both methods are available in Python. But let's use the traditional method. Traditional method means you have additional cup. So you are going to put this marks I into the additional cup. Now to marks I, you put the next one. Let's say mark I is coffee and this is tea. So coffee to the additional cup. To the coffee cup, you put tea because now coffee cup is empty. And to tea cup, you put the content in the additional one. Understood the concept? If not,
Yes.
please ask, right? So you need additional one. To
Yeah.
additional one, you put the number in the here 23. You put, if it is required to change, you put this in temporary, and to the particular one, you put the other one, and other one can be filled with the temporary one. So this is how the swapping process happens. Okay, this is the end of first round. Okay, let's see the result. Print. I'm going to print the marks. After first round, I'm going to print the marks. So let's see. Okay, bubble sort. Py. This is my results. 23, 21, 12, 43, 56. So here 23, 21, 12, 43, 46, 56. End of the first round, you will get this result. But how many rounds you have to do this?
3.
Yeah, you have to do this multiple rounds. So worst case, you have to go for 4 rounds, no? So if
Yeah.
there are 5 items here, n minus 1 means you have to go for 4 rounds. So then what I'm going to do, I'm going to tell that, okay, for k in range, length of marks minus 1, you need to go for 4 rounds. Length of marks -1. For 4 rounds, I'm going to indent everything now. I'm going to do this for 4 rounds. Right? 4 rounds, I'm going to do this. So let's run.
Okay.
Okay, end of the first round, end of the second round, end of the third round, and end of the fourth round. So we found that end of the third round, it is sorted. Here also 12, 21, 23, 43, 56. It's sorted. But the algorithm suggests us to run 4 rounds because that is the worst case. Understood?
I see. Yeah.
Right? Right. This is called bubble sort.
Yes.
Right. So I just need to explain the concept. That's why I built from scratch. You can watch the video again and again. Rather than, so some students used
Yeah.
to by heart this. Some students used to remember these codings. But the thing is, remembering won't help if you cannot understand. So you can stop this with 4 rounds. Right? You can stop this with 3 rounds. How to stop this with 3 rounds? You can keep a sub counter. Okay, I'm going to keep a sub counter. Swap counter. So initially sub counter is 0. Right? So when there's a sub, I'll count that sub. So after changing that, I'll use a sub counter. The sub counter, I'll keep sub counter equal sub counter +1. I'm going to count. Right? So after the round,
Right.
after the particular round, I'm going to change that sub counter back to 0. Right? Sub count. So the sub counter is counting from the number of subs. Then,
Okay.
so after the round, after these all these things, maybe I can make this here. So I can put this here. When you are beginning, the sub counter will be 0. But you can check like this, right? Here, so no, the sub counter should be 0 in the large one. Sorry, large one. Because the small one you have to count, and come. Then large one it says 0. Okay, before it makes 0, what I can do, if sub counter is 0, I can break. Means you start with sub counter 0 and then you count the subs. Count the subs, count the subs, count the subs, count the subs, and come out. When you come out, if it is 0, that means no subs, no?
Yeah.
If it is already 0 after coming here, if you check in no subs, if no subs, that means it's already sorted, no?
Yeah.
So then no need to sort it again, right? You can break. Right, let me run this. Oh, counter. I need R here. R, okay. Now here also I need R.
So do we have to keep swap counter equal to 0 before the 4? Oh, okay.
This one, no? This one is dangerous because in the first step, it's a step, it will break them.
Right.
Right. So let me check. So again, so this is not defined, so you can't check like this. So you have to check this after this. So sub count is initially 0. Then after running this code, you have to check the sub count. If it is, then break. So let me run. Okay, now 3 rounds. Okay, so?
Yeah.
So if it is already sorted, let me give us already sorted one, 12, 23. Already sorted one. Then the first round itself, it's over. So I can first print this. Right? Then it will go only one round. Here, one round sorted. To make this algorithm better, you can use a counter. So let's give a worst case scenario. Worst case scenario means large number, small number, another small number, another small number, another small number, and another small number. This is worst case. It's given on reverse order. Then it's going how many rounds? You have 1, 2, 3, 4, 5, 6 items. It's going 5 rounds. 1, 2, 3, 4, 5 rounds to sort. I think you can practically understand the concept now.
Yeah.
Right? Okay, I think you better write down, and the stack and queue part is remaining. So what to do about that?
We can do on the 15th, sir.
In between day. Okay.
Yeah, I have an exam on the 14th, 15th.
Okay.
We can do Tuesday.
Tuesday. Right, okay. In morning or evening?
Anytime.
Anytime. Okay, in the morning, actually, I have a class 9 to 11. So after 11, I can arrange a time. Because in the evening, also, I have another class. In the evening means after 5, again, I'm having some classes.
Right.
Okay, please write down this. Please write down this. Okay, since if in case if you miss any classes, so in case that's why I'll explain the concept of stack and queue quickly.
Okay.
So what's happening in stack and queue? Basically stack. So here I couldn't discuss this one too, right? The Fibonacci one. So anyway, so stack is something like this. Assume that you have a tank. Right? You have a tank. And stack is basically how you put the numbers or put the values into computer's memory. So let's take this as a tank. When you fill the tank, the first level will fill. So this will fill first. When you fill the tank, this level will fill first. Then it will fill this level. Then it will fill this level. When you take water, you have to take from the top. Take from the top. And again take from the top. Again take from the top. So that is the concept. So stack has the addresses. Stack, let's say these addresses, I'm giving samples 1, 2, 3, 4, 5. But there's a special register called stack pointer, SP. Stack pointer register will remember, initially it will be -1. So if it is addressing like this, if the initial address will be -1, let's start 0, 1, 2, 3, 4. If stack pointer is -1 means stack is empty. If stack pointer is -1, that means stack is empty. So when you put something, let's assume you put number, you want to do a calculation using stack. I'm saying x equal 4 plus 3 multiplied by 5 plus 8. I want to do this 4 plus 3. I want to multiply that by 2 plus 8. I'm going to use the stack to do this. So initially I'll put 3 to stack. When I put 3 to stack, this will increase by 1. Now stack pointer is 0. It will remember the 0th point only. When you access from the 0th place, it will give the value 3. Understood? When you access point from the 0th point, what is 0 point? In 0th place, you have 3.
3.
Right? So then you put 4. First you put 3, then you put 4. After 3, you put 4. And this will be incremented by 1. Now what is the stack top? It is 1. If you access, you will get 4. Right? Now you ask the program to add the numbers. When you add the numbers, stack will look at the stack top, that is 1. It will add with immediate bottom value. What is the immediate bottom value?
3.
3. So 3 and 4 will be added and value is 7. 7 is stored here and stack pointer is now 0. So then you put 2. 2 will be here. Then you put 8. This will be incremented by 1. Then you put 8. 8 will be here. You have to mention like 2. Then you again tell to add. Then this one will be added with the next immediate one. 8 plus 2, what is the value? It's 10 and stored in 1. Then you ask to multiply. Then what will be multiplied? 10 and 7 will be multiplied. And value will be 70 stored in the stack top, the 0. Then you ask to take that out. And that is the answer for this question. Okay, you have not used brackets. Instead of brackets, you have just given, you just remember one memory location, but using one memory location, you could do more. You have calculated the number. Right? This code is written like this. Push 3, push 4, add, push 2, push 8, add, and multiply. Then pop, take that value and pop to X. Store in X, memory location X. This is how you write the code. This code is called infix notation. This second notation is called postfix notation. You put the value and then fix later. Put the value and fix later. We call postfix. This is called in. So stack is used in postfix notation. And this is how stack write the instructions. The advantage is no need of brackets. No need to store brackets. Without brackets, just by using one memory location, one register to store the memory location, you can solve. One register to store the memory pointer, you can solve this. Okay, that is the idea of stack.
I see.
Right? So, and stack has another thing that is called first in, last out. Philo, first in, last out. Or you can say last in, first out. First in, last out. Why? First in will go to the bottom of the stack. You can access this after accessing all the items. File it's like You put files over files likewise. You have file stack.
Yeah.
To access the last file, you have to access the top files first. Then only you can access the last.
Yeah.
So that is called first in, last out. The other hand, it is called last in, first out. Because why? The last item you can access the first.
Yeah.
But that is kind of unfair, no? Right? So therefore, you use something called queue. QUE, QU. You use something called queue. Queue is first in, first out. Last in, last out. Queue is similar to the queue that you see in the regular places. Maybe queue in some office, queue in your maybe intercity bus queue.
Yeah.
Something like that. In the queue, the first person will access first. First come, first serve. That is queue.
Yeah.
Right? So, but stack is last come, first serve. Right? So processor use both structures because, so for an example, when I'm writing this, what will happen if my battery drained or battery get low? Will it give priority to type in or battery? Battery. So when I'm typing, if someone come and minimize this, will it give priority to type in or minimizing?
The minimizing.
Minimizing. The last in will be first treated by the processor. That is called interrupt handling. So that is also required. In the other hand, when you copy in the files, so this file copying will be done from some order. That is like first file will be copied first. So that is done in queue order. Queue is also required and stack is also required. When you are working, okay, when you are listening to this lesson, suddenly a call comes. So from your father, you have to answer that. That is stack.
Yeah.
You have to refer to your stack and answer that. But the lessons you have to done one after the another, one after the another. That is queue, right? So you need both in life.
Yeah.
You need stacks and queues both in life. Okay, that is the concept basically. So I'll give you the implementation in the next day.
Okay.
Okay, then let's stop from here. If you have any questions, you can ask, or you can send it to me using WhatsApp. Right?
Okay.
Okay, then bye. Have a nice day.
Thank you, sir. Have a good day.
Okay.